Let me show you two prompts. Prompt 1, build me an app where my team can submit requests and I can approve them. Okay. Prompt 2, build me a Next.js app with a form component that writes to a Supabase table with role-based authentication so only admins see the approval dashboard, and a webhook that sends a Slack notification on submission. Same tool, same idea, completely different output. The second one gets you something you can actually use, and the only difference is about a dozen words. Right now, everyone's talking about vibe coding, of course, and AI can build you real software in literally minutes. But here's what nobody is really talking about. The quality of what it builds is completely determined by the words you use to ask for it. And if you don't know the right words, you're just going to keep getting toy demos that fall apart the moment you try to use them for real work. Words are powerful. So today, I'm giving you the full cheat sheet, roughly 20 terms, split into 3 tiers from the stuff you basically already know up to the words that make AI build you production-ready tools instead of broken prototypes. By the end of this video, you'll prompt like that second example without thinking twice. And if you want to learn more about these systems end-to-end and how to build them, not just prompt them, then join my community at Stack Labs. Links in the description. But before we get into all of these terms, let me tell you why this video needs to exist in the first place. So the tech industry has spent decades wrapping up simple ideas, I think simple ideas, into intimidating language. I don't know all of the language myself, but I've learned enough to break through the jargon. And the idea about this is making sure that you understand enough so that you can just prompt properly. Because when you understand the meaning behind things, then you can use the words effectively. And that's bad news for anyone charging you a heap of money to do this for you. But it's time to pull down the curtain. Let's think about why this is important. So let's take IKEA as an example. IKEA sells furniture in over 60 countries. Same instructions everywhere. No words, none. They basically just use diagram. They made a deliberate decision here. If they were to use a technical language, they wouldn't have as much adoption. So if they were able to make the instructions simpler and make their builds simpler, they'll sell more product. And they have sold a lot of product now. It definitely worked. People who had never touched a power tool started assembling entire kitchens. IKEA didn't really dumb down the furniture necessarily. They just stopped making instructions feel like a foreign language. And we see the same thing happening now with software tools. AI tools like Lovable, Cursor, and Bolt, they can build real legitimate software. The instructions are actually the problem still. Your prompts do need to retain a little bit of that developer jargon in order to get the most effective results. And this is probably always going to be the case, unfortunately. But knowing the right unlocks, knowing a few little key phrases or how to frame your thinking and your prompts will make all the difference. And I say all of this as someone who spent, over 10 years shipping enterprise-grade software within large teams with multi-million-pound budgets. I've sat in rooms full of architects, engineers, throwing around so much technical jargon, it's not funny. And I had my moments in my early career where I would nod along pretending to understand everything and intervene only when it was really necessary. But I've grown and I've learned a lot of stuff, but also learned to try to break through some of that jargon as well and hit it head on. The difference is that you don't really need to know most of the words. You need to only know a select few and the core concepts that they're referring to. So let's get into it. Tier 1, the first part. Let's start easy. These are probably the things that you've heard before, you might even half know, and you've never been confident enough to use them in a prompt, but that will change now. Database. Okay, this one is pretty straightforward, and you probably already know it. It's just a spreadsheet. A database is a spreadsheet with multiple tabs and links between them all. So if you've dealt with structured information with columns and rows in a spreadsheet before, you'll get the concept of a database. A database is basically a much more scalable version of Google Sheets, where you can have many, many users, many, many sheets, and they're all nicely connected together. That's what we call a relational database. Okay, the next one is front end. Front end is everything that the user sees and clicks. Buttons, forms, dashboards, menus, that type of stuff. Anything that you can look at on a screen, that's the front end basically. And if ever said, I want it to look like this, or I want it to show me something, then normally that will be through a front end interface. Nothing too complicated here. Back end. Okay, the back end is everything the user doesn't see. So it's the opposite of the front end. It's the machinery behind the curtain. When you click submit on a form, the back end is what decides where that information goes and what happens next. The front end is like the face of the application, and the back end is maybe the brain. It's the often referred to as UI, so user interface, and it's basically a fancy way of saying what it looks like and how you interact with it. When you tell an AI to make a UI clean and minimal, it knows exactly what you mean, much better than make it look nice. Dashboard. Okay, the next one, a dashboard is a screen that shows you data at a glance. So think charts and things like that, numbers, status, all of that type of stuff. A dashboard is presented on a front end, but it's more specific than that. If you've used things like Google Analytics or a Stripe dashboard, then you know what a dashboard is. It's basically a way of presenting information in a clean and friendly way. API. This one sounds scary, maybe because it's an acronym. You don't even need to know what it stands for, but it's genuinely simple. An API is like a messenger system. It's how two pieces of software can talk to each other easily. When your app needs to pull data from Stripe or send a message to Slack or check the weather, these types of things, it will often use an API. You don't need to build the API necessarily, you just need to tell the AI quite often that it needs to interface with an API. That's enough. Okay, that's tier one. If these were too obvious, we're going to move on to a few more technical concepts, but at least you've got the basics done. So let's move on to tier two. These are the ones where you might need to Google the term or end up on Stack Overflow, read a few paragraphs of jargon explaining jargon, and close the tab. Each one of these will have a simple 1 or 2 sentence explanation so you know what's going on. Schema. Okay, a schema is a structure of your database. It's the plan that basically says this table has these types of columns, and this column holds text, and this one holds numbers. Think of it as column headers almost in your spreadsheet, but they're agreed up front. So when you tell AI, here's my schema, you're giving it the blueprint for how your database is actually organized, and it will massively improve what it builds as a result. CRUD, C-R-U-D. CRUD stands for create, read, update, and delete. That's it. Those are the 4 things that you can do with data, basically, when you think about it. So you can create new data, you can read data, you can update data, or you can delete data. This normally refers to the things that you can do via a database, but is implemented on the UI, for example. And when you tell AI, for example, that it needs to be able to CRUD on a specific point of data, then it knows that it needs to do all of those actions so that you can manage it as a user in future. 4 letters that replace an entire paragraph of explanation just by using CRUD. Component. A component is a reusable building block in your interface. So a button, for example, is a component. A navigation bar can be a component. A card that displays a user's profile is a component. When you say build me a card component that shows the project name, status, and due date, for example, the AI will build a block that gets reused everywhere. It's much better than describing every screen individually. So referring to stuff as components helps the AI know that it's going to be used again, and it creates it in a way that can be done. Authentication. Authentication just means how the app knows who you are. It's the login system, email and password stuff, you know how you always see those Google sign-in options, magic links. It's all authentication. When you tell an AI add authentication so only logged in users can access the dashboard, it's knowing what to build. Without this word, you'll be fumbling through and making it hard to understand the proper concepts about how you manage users. But if you're ever mentioning logging in, restricted access, all of this type of stuff, it's related to authentication. Query. A query is a question you can think of, but when you're asking your database. So a query might be, show me all orders from last month, find every customer in London, count the open support tickets. These are all forms of queries. When you tell AI to write a query that returns all users who signed up in the last 7 days, It's basically writing some code, maybe it's SQL, that will then commit that to code and turn it into something that's asking the database a question. Webhook. Okay, a webhook is an automatic notification between apps. So when something happens in app A, it can ping app B. So think of it like that. An API that we mentioned before is often asking something. So you go to another app and ask it something and it gives you information back. A webhook is more about telling something that something has happened. Hey, the notification, something has happened you need to be aware of. It's just one app tapping another app on the shoulder and saying, hey, you need to know something. Modal. Okay, a modal is a pop-up box that when you click delete, for example, a little box appears and says, are you sure? That's a modal quite often. When you click edit profile and then a form slides in from the right or left, and then you can edit it within that pop-up window, that is a modal. That's it. Honestly, modal, I'm not even sure why I added it. It's probably the most unnecessary fancy word of the list. You can just say pop-up. Yeah. Remember, AI is getting better and better at using more human language for this stuff, but it is good to know the specifics in case you get caught out with some of the nuances. Okay, that's tier 2 done. 7 terms, each one as a sentence or two, and that'll hopefully help you improve your prompting. Quick pause. If this is helping you understand how to build products better, then please hit subscribe and you'll get more content like this in future. All right, let's get into the juicy stuff. Tier 3. This is where we get a little bit more interesting. These are the terms that separate vague prompts from ones that will produce production-ready software where the AI fully knows what you're trying to achieve. You won't necessarily be using them all the time, but they're great to know. Environment variable. Okay, an environment variable is a secret that your app needs to know and run, but you don't really want it baked into the code. So you want to keep it nice and secret. Your Stripe API key, for example, or a database password, your email service credentials. These types of things need to be stored in a special place so that it doesn't get exposed to the internet. When you hear all these horror stories of, data breaches or software being hacked and all this customer information being leaked, often it's because secrets haven't been managed properly and environment variables in particular haven't been used as they should. So when you say store the Supabase URL and API key as environment variables, it will handle security a lot more effectively. You can also ask about what the environment variables are for the project and where secrets are held, for example. Deployment. Okay, deployment is basically the act of taking your software from it works on my machine to it's live on the internet for anyone to use. That's all it means, really. Most AI tools build something that runs in a preview, and they can deploy under their own system with a real URL. So they're effectively doing the deployment, but you may need to consider about how you deploy using your own systems on your own URLs, for example, and control that process. So just remember, deployment is the process of making something available for others to use. Role-based access control. Technically more than one word, but we'll cover it anyway. This sounds a little bit intimidating. It's not. It just means that different users see different things based on their roles. So whenever you assign, these admins or user type roles in a product, it typically controls the functionality that they can do. So managers see the team's data, but regular users, for example, only see their own data. So when you say add role-based access control, for example, basically you're saying I want to control who sees what, and the AI will build the permissions layer properly. And without this, you may be exposing things to certain users that you didn't want to. In particular, this is very important for admins of specific systems that can see all types of data across the entire product versus specific users that should only be able to see a subset of that. Serverless function. Okay, a serverless function is a small piece of logic that runs in the cloud. It's not needing a specific server. So it's like hiring someone for a very small task instead of employing them full-time, if that makes sense. So running a serverless function that checks if the email is valid before saving it to a database, you don't need to manage the infrastructure. You just describe the task in the cloud that handles the rest. You probably won't be asking for these, but it's often that the AI will suggest using this, and now you know what it means. Migration. So a migration is a structured change to a database. When you need to add a new column or rename a field or change how your data is organized, for example, you do it through a migration, not by just editing things live. It's like tracking changes in an Excel document, but for your database structure so that you know what's happening and how it's changing. When you say create a migration that adds a status column to the projects table, it generates a safe way of reversing those changes rather than just directly editing the table itself. Row level security. So this one's specific to databases like Supabase, but it's incredibly powerful. So row level security means each user can only see the rows of data that specifically belong to them. Somewhat related to the role level access that we talked about before, but this is more at a data level. So when you say enable row level security, so users can only read and write their own records, you've solved one of the biggest security risks that your product will potentially have, which is making sure that individual users can only see and edit the information that they have generated themselves. Relationship. So I actually mentioned this before when we talked about the database. In a database, a relationship is how two tables are connected. So a customer has many orders. An order belongs to a customer, for example. That's a relationship if we hold those things in different tables. So when you tell an AI, for example, to create a one-to-many relationship between the client's table and the project's table, what we're saying here is that one table that has an entry can have multiple relationships with another. So when you think about how tables and data relates to each other, you can talk about relationships when communicating with the AI. And that's tier 3 done. So 7 terms that turn a vague prompt into a professional spec. Just remember, you don't need to memorize them all. You just need to know that they exist and roughly what they do. So when you're describing what you want or when the AI uses them back to you, you know what it's talking about. And instead of fumbling around or just guessing, you know what it might mean under the hood. So let me bring this full circle now. Remember those 2 prompts from the start? Let's look at that second prompt again. Build me a Next.js app with a form component that writes to a Supabase database with role-based authentication, so only admins see the approval dashboard, and a webhook that sends a Slack notification on submission. Right, we talked about form components, database, dashboard, webhooks. They're all there. Much simpler now. So that's it, a complicated prompt in just 5 terms that this video was able to string together. Hopefully that helps you on your journey to busting the jargon, and the barrier between you and building real software is much easier. Remember, it's not necessarily about intelligence. It's a little bit about vocabulary. It's just knowing those little things that help you go from complete beginner to intermediate to advanced. Often it's just language. Now the next question is, what should I be building? What tools do I actually use to build with? Because knowing the words is good, but having the right stack is important, and that's what I made a video for that you can go check out now. I break down in this the 5 tools I use to build production-ready internal software as a solo builder.